the FEM, okay, the simulation when we should do. So we should do before the product is created, or after the product is designed, or after product is released and sold to clients. So where we should do FEA, that is finite element analysis. So as Sachin told, it should be before product is created, right? Right, students?
Yes, sir.
So be careful. Always you should analyze. Look, when you should create, when you should do the simulation, you should know. So after product is released and sold to client, so there is no need for FEA, right? Because already you have created the model, the product, right? So there is no need for FEA. So if you do FEA, if you first you should analyze the using FEA whether the product can sustain the loads or not. Okay, if it is okay, then only we should go for manufacturing the products, right? So this is what we know. So right, students. So this is very important to understand. So when you should do the simulation, that is FEA. Okay, you can use the MATLAB or you can use any software. Okay, the Hypermesh or ANSYS, or you can go for Abacus, Nastran, and Patron. So there are a lot of analysis softwares are there. So we should do FEA, that is finite element analysis. Okay, before the product is that is before the product is released to the market. Okay. Next, we will go for the next slide. So I think here you can see, right. So I think in the right you can see there are two figures are there. So what is this? Can you even tell me what is this?
So first one is like various prototypes. So like for a particular product itself, you can make various design and see which one the client likes, and based on
Okay.
that, you will test it on and then you'll release it. Sir.
Okay, good. So you can see, okay, if you assume to create a phone, okay. So if you want to create a phone, first we should try. If we should try it by using the different ideas. Okay, that is called as you may think in a creative manner, or you can go for innovation. So basically, see these five prototypes indicates, okay, what are the different ways? Okay, what the design thinker has been given. These are called as ideas. So you can see there is a like rectangular, like a semicircle, then rectangle, right? So these are different types of prototypes. Okay, what the design the design thinker will think, and he will give for the these are the ideas whatever is it. Okay, these are all he will give for the product design engineer. Okay, finally he will decide, okay, which design is good or not, which design is good for our customers. Okay, the customer is asking the rectangular like phone, mobile phone. You can see this is right. So this is, I think, fourth prototype. Fourth prototype, you can see there is a triangle. So we see different types of prototype is given by the design thinker. Okay, then regarding to the designs, whatever the ideas is, what are the ideas that is given by the design thinker. Finally, the product design engineer will decide, okay, which product or which design is good for the customer needs. You can see in the left hand side. So the first point is, when designing a new product, you have to select the best option from a range of possible choices. So this is five. Here you can see there are five different designs. So in this you should select, okay, which the design is best. Okay, so best in second point, best in class design will not cost more in time and money to design and produce. So you should take a good idea, okay, which you should convert into the product. So here you can see there are five prototypes. In that, I think it means he has taken the second prototype, right? He has taken the second prototype to manufacture the product, right?
Yes, sir.
So for that, see, once he has taken the second idea, okay, then you will convert that idea into into the design. Okay, first you will write the sketch prototype. After sketch prototype, okay, you will show for all the departments. Okay, if they tell okay, then you will go for dimension. Okay, after giving the dimensions, you will directly give for the design department. Okay, design engineer. So they will convert the idea, okay, the sketch prototype into the modeling, okay, by using the solid edge, or it may be CATIA or whatever it may be. They'll use the design software and they'll convert that idea into the reality, okay, in the form of 3D. So after that, this 3D model will be given for the FE analysis. Okay, so they will apply the load on the where see according to the customer needs, the customer will tell. So this is the boundary conditions. According to that boundary conditions, okay, FEA team will apply the boundary conditions and they will say whether this design or whether this design is okay for that particular load, whether this material can withstand. See if see if you are using this steel, okay, for outer casing, whether this material can sustain the load or not. If you use plastics, okay, carbon fiber reinforced plastics, okay, whether this plastic can retain, okay, that much load or not. So example, okay, so they will use different materials and they will try, okay, if I apply this much load for the phone, okay, wherever it regarding to the customer needs, whether the phone can sustain the load or not. Okay, once it is okay with the load, then you will say for design for the product design engineer that the design is good, so we can go for manufacturing the products. Okay, so that only here it means here you can see in the third paragraph, means third line is given. So it might cost even less and everyone will be happier. So after this, not only selecting the design, okay, the material, okay, what we should select, okay, it should cost less, as well as what are the equipments, okay, that we are using to manufacture the products. That is, manufacturing the product should be easy, and it should cost less. So that is the main criteria. Okay, selecting the design should be good according to the customer needs. Again, selecting the materials also, means you should be careful, because if you use steel example, so that is more costly, so that they will go for plastics, that is carbon fiber reinforced plastic, so that costs cheap. But they should analyze what should be the thickness, okay, because if you apply this much load, okay, can the mobile phone can sustain that much load or not, so that they will increase the thickness of the, what you can say, the plate, okay, so that the load can sustain. So they will be keep on applying they will be add the thickness like 3 mm, 3.5 mm, 4 mm. Okay, they will be adding thickness of the the plate, and they will be analyzing, okay, for how much thickness this load can be sustained. And finally they will do FEA, that is called as FEA simulation, needs to design the best possible product. So this is what, okay, if you do FEA, then you can say what should be the thickness of the product. Okay, finally the design will be done by the how to can say the product design engineer. Okay, that is called sketch prototype, and they will be the dimensions, initial dimensions. Then you will go for design engineer. Okay, you'll convert the ideas into the reality, the real product. Okay, only whatever the product design engineer, okay, designs the idea, okay, you'll convert into the reality. Okay, you will not decide whether I should give 5 mm thickness or 6 mm thickness or 8 mm thickness. Okay, that will be decided by the FEA team. So finally, that model will go for FEA team, and they will analyze. They will apply the boundary conditions according to the customer needs. Always you should analyze. Okay, you should not put your boundary conditions. Okay, whenever you means your FEA team. Okay, you should not put your boundary conditions. Okay, regarding to the customer needs. Okay, they will tell. So this is the boundary conditions of our product. So you should apply according to the customer needs. Then you should tell the results. Then if your team will add, if this load is not sustaining, then they will be keep on adding the thickness, or they will try to optimize the product, optimize the design. So okay, still the load which is coming on the product, okay, it should sustain. Okay, till that time the FEA team will be doing the optimization. So I think next in the next slide you can see see those things. Students, can you see this? Can you see in the
Yes, sir.
last? In the last, you can see, right, in the right end, in the right end at the last. So initial reason was this. See how the FEA team has done the optimization from year to year. So this is called as bracket, right? So you can see from first figure to second figure to third figure to fourth figure, right?
Yes, sir.
So this is called as optimization. So what they're doing here? Can anyone tell me?
Sir, like they do the stress analysis and all the tests, and they see like where simply the stress concentration is less and the material is not required. They're just reducing the material, so the price of the what do you see, the product reduces.
Good, Sachin. The same, whatever the Sachin told. Okay, it's same. So first, huh? So uh,
But for first semester, today, Thursday, 10 paper.
Students, 2 minutes. Ma'am, but I am in class, right? I'm in class. I don't know because I'm having class now. I cannot leave the class. I don't know, ma'am, because I'm in class, right? What I can do?
That's what, sir. We don't know. For compensating labs, they
They whatever they do physics, chemistry they can do. For mechanical, we have class. Suddenly we cannot tell others to take the class.
today and tomorrow, sir.
So anyway, ma'am, you tell them.
Don't know, sir. That's what even I
Okay, Livji, anyway they will do. Why you worry? Anyway, see, sir, if you didn't call, we will tell.
Athena is having CAD
Uh,
into workshop
why?
as per tested and
Okay, leave. So, see, come to the class students. Anyway, so this is called as topology optimization. Okay, if you go for hypermesh, okay, so there'll be team in the, if you go for any company, mechanical company, MNC company, there's a team called topology optimization. So this is used for only to analyze where we should remove the excess material. So first they will take the first figure, okay, the first figure, and they will try to apply the boundary conditions, and they will see wherever the stress is less, so they will remove, so they will not remove the excess material. Okay, the software itself, it will remove the excess material. So I think the designer will, or who are doing the optimization, okay, they will not remove the excess material. They will do the topology optimization. Once you get the stress analysis, so wherever the material is not required, okay, it will remove it by itself. And finally you can see the third figure. The third figure indicates, okay, this is called as optimization design. You can see for this, so your material cost will be, see, material, okay, that will be used for manufacturing the product will be less, right? So, right, students, because
Yes.
materials is removed, so that you can save the material cost, right? And you can save the equipment cost also by using the third figure, that is topology optimization, the design. Okay, you can save the cost, material cost, as well as you can save the equipment cost, okay, to manufacture the product. So this is called as topology optimization. So this will be done in the hypermesh. Only you have in hypermesh, that is called as topology optimization. Okay, so they said there will be a team in the MNC companies. If okay, this team job is only to do the stress analysis, and after that they will do this topology optimization. Okay, why they will do topology optimization means to remove the excess material in the product. Okay, they, wherever their stress is less, so automatically the this topology optimization, immediately it will do stress analysis, and it will remove by itself the excess material. Wherever the stress is less, it will remove by itself. Okay, this is the, now you can see first design is this, in the first figure, and it will convert into the what you can say into the third figure. Okay, so this is what is called as topology optimization. So anyone has any doubt in this?
No doubt, sir.
So this is called as optimum design. So this third figure will convert, okay, the whatever the design which is given by the product. See, product design engineer will give the first figure. Okay, and in FEA team, once they do this topology optimization, they will convert to third figure. Okay, the third, what you can, third design. Then this optimum design, okay, will be given back to the product design engineer. Again, we will check whether the design is okay with with all the other department heads, as well as the customer. The main is the customers. The customer should satisfy the design. If the customer is satisfied, then they will go for manufacturing, right? So here you can see in the first line, searching for optimal design is not easy and takes time. We generally choose something close to what we think is optimal. That is called as, see, this is the customer needs is this. So how we can meet the customers? Okay, first the design thinking team will come into picture. They will empathize the customers. They will ask the needs by them. Then they will convert that into ideas. Then that idea will be converted by product design engineer. Okay, he will draw the sketch prototype, only sketch prototype and dimensions. Then the product design engineer gives all the information for the design engineer. He will convert the sketch prototype, okay, or concept prototype into the 2D model, sorry, 3D model. You will convert that in 2D, then 3D. After that, it will give for FEA team. So FEA team will try to do this analysis, and they will find the stresses, and lastly they will use the topology optimization to remove the excess material wherever there is no need. Okay, there is a no need of materials in the product. Okay, it will remove by itself when you do the topology optimization. Okay, this is called as what I can say. We can reduce the cost. Okay, we can reduce the cost by doing this topology optimization. So mainly for that only they will do. Topology optimization is used for removing the cost. So anyone has any doubt in this? Then you should ask me.
No doubt, sir.
So if you learn FEA, okay, if you learn FEA, this one, FEA analysis, kindly do this topology optimization. So it is very, very good. Okay. Then we will go for the next slide. Okay. At last, you can study FEA simulation provides some tools to help the conception of products, the topology optimization, and tools to check design, linear static analysis. So, see, this is only for linear static analysis. Okay, wherever if you take a structure, wherever only it should come linear static analysis. Okay, when you go for the fatigue or when you go for the dynamic analysis, okay, this topology optimization is topology of this design, okay, is not okay. Then after converting the original design into topology optimization, then again you should do the fatigue analysis, then the dynamic analysis, that vibrations, everything you should do depending upon where this product is moving into picture. If you take bracket, okay, you'll get fatigue, students. You should do fatigue analysis or you should do dynamic analysis. Can anyone tell me? For this application,
what part is this, sir? Like on the right hand side?
So see, this is used for what you can say to connect the TV to hold the TV. That's all.
Okay,
Brackets are
got
used
it.
for only TV, the holding of TVs. So whether can you tell me whether dynamic load comes into picture here?
No, sir, it's static load, sir.
Okay, then fatigue.
Fatigue is only required like if it's variable load, no, sir, mainly.
Yes. See, fatigue indicates if you keep on applying the variable loads, okay, there is fluctuating loads to the object. So here, if you go for bracket, okay, which is used for connecting the TV, only static load will come into picture, right? So there is no dynamic load. Dynamic load means fluctuating the loads, okay, that is called fatigue loads. If you keep on applying the different loads, okay, for the material, so that indicates the fatigue. So here fatigue will not come into picture. Creep, can anyone tell creep? What is creep? Can anyone tell me what is creep?
So what is creep, sir?
No, I'm asking for the students. You don't know what is creep?
Forgotten, sir.
Okay, I will tell you. Wait, I think some student has been has come to class, so I will admit. Okay. Okay. See, I think creep indicates here. Creep is nothing but initially we will give the static load, okay, for the material. Okay. After that, okay, if you keep on applying the temperature, okay, we will keep on applying the temperature for the object, and we will see at what temperature the material will get failure. So this is called as creep. Okay. Initially we'll give the static load for the material like 50 Newton force or 60 Newton force. After that, okay, we'll apply the temperature. Okay, we'll keep on apply the temperature for the material, and we will see at what temperature, okay, the material will get fractured. So this is nothing but creep. I think everyone has understood what is creep and what is fatigue. See, fatigue will not discuss with the full temperature. Okay, students. Hello.
Okay, sir.
Okay, fatigue indicates only we will apply the fluctuating loads or repetitive loads. So we will apply repetitive loads for the body, and we will see how much number of cycles that the material can withstand. So that is the ultimate fatigue. So how much number of cycles that a material can withstand is called as fatigue. And creep indicates initially we will give this static load for the material, okay, and then, okay, due to the temperature, okay, we'll keep on applying the temperature for the body, and we will see when does the material fails. So this is nothing but creep. Can you say Any examples for the fatigue as well as for the creep? Anyone, students, can
Sir,
anyone
for
tell?
bridges,
For bridges, okay, bridges
like even
for
the
what?
climate change will be like the change in temperature, and the amount of traffic moving on the bridges will be like variables.
Okay, that is one thing. Then I think you have an example with respect to means your application. Mechanically, if you go for engine,
The engines, yes, sir. Car and all those things, sir.
this engine is the best example for your creep, right? So fatigue as well as creep. So if the piston moves with a constant velocity, okay, that indicates okay, you are applying the same force, okay, for the object, and due to the what you can say due to the spark which is ignited, so that's called as once the combustion happens, so there will be temperature will be produced right inside the cylinder. So due to that, the creep comes into picture. So right, students.
Yes, sir.
So this is an best example. If you go for engine part, okay, you should check fatigue, you should check creep. So if you go for industry, okay, you should do all the analysis for engine. But when you come for the fuel tank, so there's no need for fatigue. I think fatigue for fuel tank, okay, it may require, but creep it is not required, right? Because the temperature only from 35 to 45 degree, only 10 degree it may get vary. So due to creep, nothing will happen to the body of the fuel tank, right? So only due to fatigue, okay, something may happen, or due to external force, okay, which is coming onto the tank. Due to that, the tank may get damaged, right, students?
Yes, sir.
So these things you should understand. Okay, when you will do fatigue, when you should do creep. Okay, these things are very important, okay, to analyze. Then we will go for next slide. Okay. So what is this? Can anyone tell me what is the understanding of this figure? The end.
So it's like just testing the design, sir. Like after initial design, you test each and everything. Like you analyze it, and after that again you edit it, and again you reanalyze until you get the optimal solution.
Okay, good. So this is the thing. But first, okay, first the design. What you can say, the product designer will give the design for the FEA team. Then how they will optimize. Okay, optimize from initial design is nothing but here you can see, right. So on the right end. So you can see first step is initial design. So you should do analysis for the first design. Okay, then you will go for design modification. So okay, if you assume that okay, it can sustain more, if it sustain what you can say, the stress which is produced inside the material is very less. Okay, that indicates you are using more material, right, inside the more material, okay, in the product. So then what we should do, then we should go for topology optimization, right?
Yes, sir. For removing the unwanted materials, sir.
Yes, it's unnecessary. Whatever the excess material you're using, okay, we should remove those things because the stress which is induced inside the material is very less. Okay, if you assume the yield point or yield stress of the material is around, if you use steel there in this application example, this is an example. So it is 270 megapascal. Then when you do the FE analysis, whatever the customer is giving the input for you, so we are updating the boundary conditions. I'm fixing at one end and I'm applying the force at another end. Okay, if the stress is only 0.004 megapascal, then what is the meaning of that? So yield stress is 270 megapascal, and the stress which is induced inside the material is only 0.04 megapascal. So what does that indicates?
So can you repeat the question, sir?
See, the yield stress of the material is 270 megapascal. Okay. Then if you're using this first model, okay, what the product design engineer is given, then I'm applying the boundary conditions according to the customer needs, and I'm checking, okay, what is the stress, so that is induced inside the material is around, I get around 0.04 megapascal. So what is the meaning of this? Yield
So
stress
it
is
can't
270
take the
megapascal.
desired load, no, sir. Like if at start itself it has this much of like the what do you say the load it can take. So it should be designed on basis like it can withstand that amount of load.
Yes. So that's only, Sachin, I'm telling you. See, if I apply the boundary conditions according to the customer needs, assume the yield stress is 270 megapascal, 270 megapascal, and the stress which is coming in the material is 0.04 megapascal. What is the meaning of this?
So the design is good, sir.
The design is good. Then that is okay. That design is very good because the stress is only 0.4 megapascal. So when it reaches around see, always you should remember this is a factor of safety, right? I think this I told you in the previous semester in mechanical operation. What is factor of safety?
So it's like kind of if you're making a material which is supposed to withstand like 10 kg of load, you need to make somewhat like into 2 or into 3 times. So it can like for scooter, you give an example, sir. Scooter is designed for 2 people, but even 3 people, if they are sitting, it should work properly.
Okay, good. So this called factor of safety. So factor of safety is nothing but always you should remember. So they will tell, okay, the allowable stress or the safe stress is around 90 megapascal. So the industry only they will tell, okay, the available stress or the safe stress of for this material is around 100 megapascal. Example, that is if the material is yield stress is 270 megapascal, okay, they will divide by 3 or 2.5 or 3 or 3.5. So that depends upon the application. If you go for aerospace, you will tell 1. Okay, you divide by 1. If you go for automobile industry, they will tell 3. Okay, 270 by 3 is 90. So that indicates, so if stress reaches 90 megapascal inside the material, so that indicates in the industry, okay, they will tell the material will get failure. So that is what means they are following in the industry. So if the stress which is produced inside the material is only 0.04 megapascal, see, the material can withstand till 90 megapascal, right? According to the industry right now.
So what device, sir?
No, the material can withstand around 90 megapascal, right?
Yes, sir. If its factor of safety is if it's 270 and if its FOS is 3, then 90, sir.
Yes, 90 megapascal. But when we do the analysis, only it is going around 0.04 megapascal, right? So that indicates we have added the excess material inside the product. So what they will do topology optimization. Okay, they will, once they do topology optimization, okay, I think that is called as design modification 1. So this is initial model or initial design. Then we will go for design modification. When the stress is lesser, then we will go for design modification 1. So in this, they will go for topology optimization and they will check whether the stress is beyond 90 megapascal or not. Okay, again, so you can see when the stress, okay, is less than, like, I think if you got 40 or 50 megapascal, then they will go for again design modification 3. Again design modification 2, 3 and 4. I think you can see 1, 2, 3, 4, right? So there are 4 design optimization. So this is called as topology optimization. What they will do in FEA. So FEA team will do all these things. I think everyone is getting right.
Yes, sir.
So why they are given? See, if you see the final design, see why they are given, and what you can say, there's like a stand, right? There's like a
So it's almost like the basketball hooks, like what is it, stand with the hooks, sir.
yes,
Your hook is not given, but it's somewhat similar to that, sir.
Okay, why they added this excess material here? Can you
Extra support, sir.
Inclined one. Why they are given that inclined line in the design? Can you tell me?
So it's kind of extra support, sir.
Extra support. Okay, good support then.
So like because if the load on this side is like more on what you say on the top side.
Okay.
So if it's like joined with this in a certain angle, it can reduce the amount of load on it, sir.
Okay. Good. Okay, good. Anyways, Sachin. So here you can see. So there will be edges will be there, right? So there will be corners will be there at the end. So due to that corner, there will be more stress there will be more stress concentration will be occurred. So for reduce the stress concentration to take up the load. So for that reason, okay, they are given that extra material here, that inclined one. That inclined one is given for taking the extra load. Okay. So this will reduce this more stress concentration on the edges or on the corners. Okay. Okay, students.
Okay, sir.
So this is what they will do in the if you go for industry, they will follow these things. Okay, first as a product design engineer, okay, you will supply the design, okay, for FEA team. So they will try the design modification. They will take time, and finally this design will be given for the design product design engineer. Again, he will check once again. He will show for all the department heads as well as the customer. The customer satisfied, then immediately this design will go for manufacturing. This is done for only the linear static simulations. Here, linear static simulation is mainly used for design checking. Okay, because the load, because the load it should sustain, right? It should not go beyond the 90 megapascal, right? Considering the FOS, I'm telling you, with considering the factor of safety. So it should not go beyond 90 megapascal, right, students?
Yes,
So
sir.
first we'll check the linear static analysis. So once the design is okay, then we will go for the fatigue or creep or dynamic or mode shapes. Everything will go later. Okay, thermal analysis regarding to the application. But first we will do this linear static analysis. After this linear static analysis, once the design is okay with regarding to the with regarding to the boundary conditions, then we will go for fatigue, creep, dynamic analysis. Then we'll go for thermal analysis. Whatever you want, okay, you can do later. Okay, they will do later part. Then can anyone tell me what is this?
So it's I think it's again the same. So for manufacturing the actual product, you make a prototype and 3D model on computer, sir, and you test it out like whether it can withstand this much load, temperature, and all those things.
So this is called as you can take this is called as connecting rod. Okay, so this is called as connecting rod. So first, see, this is called as concept, right? See, concept, he has not mentioned any dimensions, right, in this. So how the connecting rod should look. So he has written connecting rod. This is called as concept sketches. So once the product design engineer, okay, is done the concept sketch. If it is okay, then it will go for design engineer. He'll convert the concept sketch into the 3D model. Okay, then FEA team will see, this is called a 3D model. Your left hand side, okay, the virtual computer model. So this is called a 3D model. Then this 3D model, okay, will give for the FEA team. So FEA team, what they will do, they will apply the required force, whatever the customer needs. So you will take the bonding conditions, you will apply one side fixed, okay, and on the other side you will apply the force, and you will analyze what is the stress induced inside the material, what is the displacement, or what is the deflection. So because this is a beam, so you should tell deflection, not displacement. Okay, deflection. Then what is the angle, what is the slope, and what is the shear force. Okay, everything, what is the moment, okay, which will be generated on fixed support. So everything will check here. So once it is okay, then it will go for manufacturing. So if you require some that is optimization, then they will go for hypermesh. They will mesh the model, they will do the stress analysis, they will do this optimization. Then after doing optimization, it will go for that design. Optimization design will go for the product design engineer. If all customers as well as all the department heads are okay, then it will go for manufacturing. Any doubt in this?
No doubt, sir.
So this completes the modeling and simulation. So if you have any doubts regarding this, you can ask me, students. So this is very important in the industry. Okay, see, I think if you read this much, I think it's enough. And if you learn some softwares, okay, like MATLAB and ANSYS, then hypermesh to mesh the model. You can do analysis also in the hypermesh. Okay, see, one thing I can tell you. Okay, today you can take a simple problem, like take a bar problems or beams or anything. Okay, you take the mom textbook, matrix of material textbook. You take one problem, simple problem, and you try to solve in different softwares. And you solve in ANSYS, you solve in MATLAB. Okay, you solve in machine learning. See, you can solve in machine learning also. So you solve in machine learning, and okay, you try to solve in different softwares, and you try to analyze in which way or in what way we can solve the problem, and you try to analyze the solution. So what you got in ANSYS, see what you got in hypermesh, what you got in MATLAB, okay, what you got in machine learning. So you can analyze in different softwares. Okay, in if you go for MATLAB, there's a Simulink. Okay, I think a lot of companies they're using the Simulink right now. Okay, for mechanical problems also they're using the Simulink, because it will solve very easily. Okay, very fast. Only thing, you should give the inputs. Okay, if you give inputs and if you solve immediately, it will solve and it will give the solutions for you. Okay, so take a simple problem. First, initially you take a simple problem and you analyze. Okay, what are the different ways we can solve? One is by using the analytical method you can solve. So any analytical method will be there in your textbook, don't worry. Okay, try to understand what's analytical method, how you solved everything, then go for the softwares. Okay, if you do this, you can now add all these things in your resume. Students, I'm telling you, if you add all these things in your resume, that you have solved a problem by using analytical method and FEA. That is FEA means you can take any software, MATLAB. Then you can take ANSYS Workbench. You can take machine learning. You can take Hypermesh. You can take the Nastran pattern. Okay, anything. First, to try to design a model, then converting the design into solution, and try to do the topology optimization. Okay, for any problems. If you take a simple problem, take your textbook. Don't go for complex problems right now. Take a simple problem and try to do the optimization, topology optimization. And if you add all these things in your resume, so that's enough to get the job. I'm telling for all the students, not only for 9 students. I'm telling for convey these messages for your friends also, 22 students. So it's enough for you to get the job. I'm telling you. Try to take a problem, do analytical method, and convert that, the design into a design. Okay, in the some software like CATIA or SolidWorks. Don't go for complex shapes. If you go for complex, so it will be difficult to design in the software. So go for simple problems. Okay. So if you want more information, you can go for YouTube also. Go for YouTube. Type how to design. Okay. If you take a rectangular plate table example, or you can go for any problem, simple problems. Okay, like a beam. How to design a beam. Okay. If you type in YouTube, okay, how to design a rectangular plate table. Okay, in ANSYS Workbench, sorry, in CATIA, in Creo, or in Creo. If you type anything, okay, you will get the solution for that. So follow these steps. Okay, whatever they given, so you can design the model. So once you design the model, then again, if you want to do the solutions, okay, go for YouTube, type there. Okay, how to solve or the stress analysis of the rectangular plate table. Okay, in ANSYS Workbench, or in MATLAB, or in the machine learning, or you can go for the Nastran pattern. Okay, you type there, so you can get the some videos. So see that videos, get the ideas, then solve the problem. Okay, then you can make a paper of that. Then you can publish the papers. Okay, and you can add those things in your to resume. So that gives weightage in your for your resume. Okay, then easily you can tell. So these are things I've done. Okay, in my I think last 2 months. So right now you have around 2 months time, 2 to 3 months. If you want to get the job, okay, in the industry, kindly do all these things. So the industry person only he'll be looking, okay, whether the students know the concept. If they know the concept, they will take immediately. So if you add all these things, like if you do like 5 to 6 problems, and if you add all the problems in your resume, that these are the analysis I have done. So these are the design I have done. So if you add all these things in your resume, you put all these things in the front page. Okay, after your education, don't put other things. Whatever the software you know, so what are the problems you have solved. So if you put 6 to 7 problems, I think they will take immediately. I think everyone can hear me, right?
Yes, sir.
ಅರ್ಥ ಆಗ್ತಿದೆ ನನಪ್ಪ, ಬೇರೆಯವ್ರು ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಬೇರೆಯವ್ರಿಗೂ ಹೇಳ್ತಾ ಇದ್ದೀನಿ.
Understood, sir.
Rahul, Fayaz, Samuels, as Ashok, kindly if you do this and tell for your friends also, do this whatever I told you. And if you want any suggestion, or if you want anything, okay, I will be there. So you send the problems for me. Okay, then I'll try to give the solution for that. So if you had 2 months time, at least if you do like 4 to 5 problems now, don't go for complex problems, go for simple problems. Okay, just take the mom textbook. Okay, and you can go for mechanics of machine or dynamics of machine, or if you can for DMA1, DMA2 problems, any problems. Okay, you take and you try to model the model according to the whatever the question they are given, and try to do the analysis. Compare the results of analytical method as well as the softwares, different softwares. So if you tell I know this much softwares, then automatically it will be good for the company, right? So company will be looking that. So how much softwares does the student knows. So the basics, they will only see the basics. They will not go for the complex problems, because once they hire you, okay, again they will give you training for you. They will give around 2 to 3 months training. They go into one domain. They go into one software. Like MATLAB means they will give you training on MATLAB. If they go for Hypermesh, only they will give you training regarding to Hypermesh. Okay, but initially to enter into the company, you should know all the little bit of software, little bit regarding to all the softwares. Okay, then only it will be easy for you to enter into the industry. Any doubt?
No doubt, sir.
Okay, and then I'll go for the next this one. So I'm telling you a lot of information. Kindly follow whatever I'm saying, so it will be easy for you to enter into the industry? Fayaz is there? Samuel, Fayaz, Rahul.
Yes, sir. There, sir.
See, what are you doing the project in your? I think your fourth year project, capstone project. Try to do in FEA also. So I'm telling you to try. Okay. So don't worry whether you will solve or you will not solve. So okay, first try to solve the problems. Okay, with respect to some softwares, FEA designing and softwares, and you try to make you mean if you solve the problem, then you can compare the results, right, by theoretical as well as by FEA. But means you can go for theoretical, or you can go for FEA and experimental. So if you do all these things, it will be good for you. Okay, you can tell all these things in your interview. Okay, if you go for interview, so that will be helpful. Then we'll go for the third module. That's 3, product development. So any doubts regarding to this second module? Kindly you should ask me. I will share this PPT in the Google Classroom, as well as I'll send you in the WhatsApp also. Okay. So any doubts you can ask me. Then I'll go for the third module. So first 2 modules are finished. Okay. So any doubts in this first 2 modules, students?
No doubt, sir.
Okay. So next we'll go for the product development. So why we should learn this module, students? Can you tell me why you should learn this new product development?
So we need to know the process to start to make a new product. Like first you just problem formulation based on the problem statement you have provided. You generate ideas from design thinking team, and from that you just choose 3 optimal solutions, and then based on that you do the process and make the product, sir. So just give you information of what processes should be done to develop a new product.
Okay, good. So here mainly the new product development phase, okay, is done to understand the customer needs and what type of product, okay, we should give for them. So that is the first thing. So I told you. So there are two right? There are 2 terms. One is innovation and invention, right?
Yes, sir.
So invention. So invention is a thing, but regarding to the customer needs, if they ask, we want a new product regarding to that application, whatever it may be. So we will go for new product development. Only if the customer asking only to try to update the technology, okay, in the existing product, then we will try to update the technology in the existing product and we will supply for the customers. So this is called as new product development. So new product means what? So we are going for invention, right?
Yes,
New
sir. Starting from scratch.
Okay, that is new product. That is called as new product development. So mainly we'll go for new product development because of one is cost, right? To reduce the cost. If the cost is very high, so we will try to reduce the cost of the product, right? If you take the car, so initially the car price was around 5 lakhs or 6 lakhs or 7 lakhs rupees, right? So right, students. So the customer is asking, so we want the car with respect to less price. So only your nano came into picture, right? 1 point something, it is around 1 lakh or 1.5 lakhs, right?
Yes, sir.
Hello. So that is an example. So depending upon the customer needs, so the customer is asking, okay, we want car with respect to less price. So only the car company has given the nano car. So that is you will get around 1.5 lakhs. So that is the best example. So that is cost. To reduce the cost, we want to go for new product development. Next is time. What is time?
So is it the time taken to manufacture, time taken to launch the product?
Yes, that is time taken to launch this product. So if you want to with respect to time, okay, we will try to manufacture like example nano car only. You take nano car only. So the customer is asking, we want a car, okay, with a less price. Like they're asking, I want a car within 1 lakh or 1.5 lakhs or maybe 2 lakhs. So they're asking, we want a car, we want to buy a car with a less price. So how much time is required to develop a new concept or new product and they are supplying for the customers. Okay, so this is called time. Within time, okay, we should manufacture we should manufacture according to the customer needs, and we should supply. And third is quality. Why do you need quality?
So like you need improved quality for lesser price. So people actually go for quality products.
Yes, good, Sachin. So quality indicates quality of the product. So only not about the price. So the customers are very, what you can say, or means they will ask more quality. The product should have more quality. It should sustain more life. So everything they will ask, again they will ask with a less price, and you should give the product within less time. So this is the objectives of the company. If you go for any company, the objectives of the company is, one is they should give the product with less price, with less time. Okay, if they're developing a new product development or new product, so they'll be trying to manufacture a product with less time, as well as the cost should be less and the quality should be high. So they should see all these things, then only they can get success in the market. Okay, if you go for nano, I think nano, see, once they manufacture the nano, okay, and they supply it for the market, I think it means the nano car is not been successful, right? So, right, students, why? Can anyone tell me why? What is the reason?
So can you repeat the question, sir?
Why
Sir,
why the
because
why the nano car has been not succeed in the market?
because Nano is like a cheap product, sir. If you give some more money, people will buy more expensive product.
No. I'm telling. I'm asking you why the nano car has not succeed in the market. Why it is not sold
So
more?
I think it doesn't have the required features compared to other cars. Like
Okay,
you
that is
can say
one.
about the engine or the speed and all those things, sir.
One
No,
is
sir, but
speed.
considering the price factor also we have to talk now, sir. In
So,
feature.
so that's only I'm telling you, Fayaz. Okay, if
So,
you give,
sir, the main reason why it failed is because Nano was 2 lakhs on road, whereas Alto was 3 lakhs. When people
okay,
saw Alto has little more status, sir. That's why Nano failed, basically.
okay. Then,
So it's
so I think,
basically because it only has less price, but if you see the features based on it, the expensive products has better features. So if they are able to produce the same product almost at the like Nano's price, like
yes.
if Nano is able to produce like the same features, then it will run a lot, sir.
Okay, good, Sachin. So this is basically I want the answers. So if you go for industry, so your aim is the company gives the aim our objectives like this only for you. Okay, so you should manufacture a car, okay, within less price. So how you will manufacture? So the quality should be good. The main thing, the nano, I think the engine quality is not good. Okay, if you use the nano, if you use around 1 to 1.5 years, okay, the engine quality, our engine will get sound. In the engine will give lot of sound. So I think that was the main reason. Okay, so engine, I think engine, whatever the engine performance was very less. Okay, so if you go for a company, okay, this should be your aim. Okay, you should manufacture a car within less price, and the quality of the product also should be very good. So the company, what I can say, the CEO will give the information, all the information for you. Okay, if you are a design engineer, okay, or product design engineer, so you should look into all these factors. The quality also should be good. The time, okay, the time to manufacture the product should be less, as well as the cost should be also less. So be careful. Okay, this is your objectives when you go for the company. Okay, so this is why, okay, you want to develop a new product development, or you should go for developing a new product. One is cost, to reduce the cost, to reduce the time, within time, and we should give the new product, as well as for quality. Always you should see the quality should be good. If the quality is not good, automatically the product will not succeed in the market. Okay, then what are the reasons for new product development? What are the needs? Can you tell me what are the needs for the new product development, that is NDP? So if you see NPD, the NPD indicates new product development. Always you should see, if I give NPD in the question paper, NPD indicates new product development. Okay, be careful. NPD indicates new product development. What are the reasons for NPD? What are the needs for the NPD? Can you tell me?
Sir, like if you launch a certain product and if there's no competitors, sale will be well, sir. And it's like based on again the customer requirements, like based on the problem statement they have given. If there's no existing product, like if you make a product, it will really sell well.
Okay. See, one is change in market. So always always the technology right now. Okay, from 2005, the technology for every 3 to 4 months. Okay, it has been changing. So due to that, okay, the companies are going for new product development. Then then that is increasing competition. So competition is right there. If you take one product, so there will be around 1,000 companies will be there. So due to the competition, all the companies are going for they're trying to produce a new product development. Okay, or they're trying to develop a new product. Then you can say growth and development. Okay, that is to grow the company. Okay, then for that they're going for new product development, right? To grow the company or to get more profit, to get more revenue. Okay, they are going for a new product development. So these are the main reasons. Okay, why the companies are going for a new product development. Okay, because lot of companies are coming to day-to-day life, right? If you see today, so there are 10 companies will be coming. If you see tomorrow, again 2 companies may come. So we don't know. So there are a lot of new products has been launched. Okay, within 1 year, you can take any one application and you see any one product and you see how much companies are there, how much new companies they're coming, they're existing daily. So what are the new design they are giving for the market? Okay, new technology. Okay, they are giving for the market. Okay, you should see all these things. Then only, okay, once you get the job in the industry, okay, once you become a product design engineer, okay, at that particular point, if you think, okay, you lose. I'm telling you, you lose. Now from now only you should think. So if you want to go for automobile industry, check how much automobile industries are there in the market. So which company are manufacturing like engine part, which company are manufacturing the transmission system, which company are manufacturing each individual parts. Okay, where they are manufacturing, where they're assembling. So everything you should know. If you go for Volvo, okay, try to analyze in Volvo what they're doing. Okay, like the Infosys. Or if you go for each individual company, okay, you should analyze what are the products they are manufacturing. Okay, what are the parts. Everything you should analyze. Okay, then only it will be useful for you when you go for the company. Then it will be easy for you. Okay, then it will be easy to work in the company. So by this, I think tomorrow I will start this. I think I have done this new product development right phase in the first, I think, second class, right? So I think I finished this new product. What is the new product? What are the different steps? So these
So I
things are
think this
completed,
we
right?
had in module 1, sir.
That's module 1. So module 1 before only I've told, because your product life cycle starts with new product development, right? For that sake, I told you all these things in the first class itself, first or second class. So same thing. Okay, same thing I should repeat here. Okay, for if you want to develop a new product, so what are the different steps? So these are different steps. Then I'll go for the next topic. Okay.
So
This is
have
the
you
third.
updated the presentation and this, sir? The
No, no,
question.
no. No. I will update today. I will update today. I will
Okay, sir.
update now. Okay. Then, students, I want to show some this one. Okay, wait for 2 seconds. Don't leave the class. So see here, kindly you should see the case study. So I will show. See, I have updated the case study in the case studies and as well as the textbooks, right, in the Google Classroom. Kindly select any one case study. I think everyone can see the
The
screen,
fourth
right?
book, sir, I think so in that.
So this is the fourth book. 4 books I have updated. So see, after I will give you the notes as well as I will give you the PPTs. Okay, if you want more information, okay, you can open these books and you can see. Okay, you can get lot of information in these books. Okay, you can get lot of so these are the contents. If you want anything, okay, to understand better, okay, open this book and you see. So there are 4 books. Okay, I have updated in the Google Classroom. Okay, open the 4th book, volume 4. I think here you can see the case studies, right, Sachin?
Yes, sir.
So here kindly, so there are 9 students. Kindly individually you can take one case studies. Okay, don't worry on report. You can copy paste everything regarding to the case study. Copy paste all these things and make the report.
So one doubt in this itself, sir. This book, sir.
Okay, tell me, Sachin.
Like it has given the case study, sir, but from where does the solution start, sir?
No, I think in the case study only means you will give everything.
Is it like both combined, sir? Okay, sir.
Yeah, everything will be there in the case study. You will give the problem statement and you will give the solutions. So don't
Sir,
worry.
like, can you just give an example, sir? Like, assume if it's the first one itself, sir. where does the case study start and end from, sir? Like start to end, sir. Just one
Okay.
topic,
If you go
not
for the
the
first
report
page-
part, just the case study part, sir.
Okay. If you go for the first page, I also not seen this book, but I told you. Okay.
So like
So
I was
this is-
reading through it,
this
sir.
is-
Like I was trying to make the report, but I
Okay.
don't know where the case study still ends, sir.
Okay. Okay.
Like I don't think they've given an explanation of a case, sir. They've just directly explained the problem solution.
Okay. Okay. Then you must create the problem statement. That's all. If you
Okay,
understand the
sir.
concept,
Yeah, I think that we must do that
see
once.
abstract. See in abstract only they will give everything. In abstract only they will give the everything, the problem statement. Then you should go for the company background, equipment, products. Okay, these things. Okay, plant PLM. Okay, so this is called as calibration across the life cycle. Okay. Anyway, I think it's 9:33. So yeah, I think any one I will take and explain you. I think in the coming classes. Okay. After
Okay,
that you can means you can take any one. So there are around 20 is there. So 9 students they can take individual one case studies and they can make the report part. Okay, only copy paste and next PPT part. Okay, PPT part you should make yourself and you should give. Okay, for that 10 marks will be there. Okay. For this.
Okay, sir.
So only assured you, kindly open this fourth book and try to analyze the case studies. So wait for 2 seconds. I will take the attendance. Then you can leave the class. Okay, students. Thank you. You can leave
Thank
the
you,
class.
sir.
Okay, thank you. Bye.